finally, here's the last objective. You're going to be able to tell the difference between continuous and discrete functions. In the picture that I chose here, I'm going to say it's the Mediterranean Sea. Let's just say that's what it is. Okay, and I broke up the words where they're at on purpose. So look at where continuous is and look at where discrete is. Continuous, it's with where the whole entire sea or ocean is. All of that water is a connected body of water. Okay? Look at where discrete is. Discrete is where all those puddles are. And each one of those puddles, they stand by themselves. The water from one puddle doesn't touch the water from the next puddle. And that's what's called discrete in terms of functions. All right, now before we talk about it with actual functions here, I'm going to give you some background, some application of these two things, something that's important to your lives, but you probably just didn't even know it. Okay, so in terms of signals, especially with sound, you've got two different kinds. You've got an analog signal and you have a digital signal. If you read any music websites, if you're totally into music, there's people that debate like the pros and cons of both of these things all the time. Okay, most of your experience in your life presently has to do with digital music, right? Okay, so here's what these things are. So an analog signal is one that's created by a physical process. If I pick up a guitar and I strum at it and the music that I hear from it, it is an analog signal. Also, if you're playing music from a speaker is moving the air backwards and forwards, that's a physical process. It's making an analog signal. Okay, lots of stuff besides sound can be an analog signal, like changing temperatures over time, things like this. This can be an analog signal if you had some device that's recording it. That is a lot of information. Okay, way back when, like your parents may have had these things called cassette tapes. Cassette tapes and records, those are analog sound like recording devices. Over on the digital side, what you're more used to, this is a numerical representation of the original data, the original analog signal. Okay, and you take it by samples. Look at it like this. When I go to see a movie is not real action. If I'm looking at things with my eyes, there's a lot of information, a lot of stuff that's going on if people are walking by or whatever. If I were to film the same thing, the camera, what it's doing is it's taking a snapshot, it's taking a picture, it's taking a picture, and it's taking a picture. Think about this. If I were to only take one picture a second and then I play all of those back, what would that look like? Or if I were taking 24 pictures a second, what would that look like? The more times that I take the pictures, the more realistic the motion becomes. And that's what digital signals are all about. You take samples, and if you take enough of them, you don't miss all the missing information. Okay? And this is not a continuous set of points. It's a discrete number of points, and it contains a finite amount of data. And this is what you want whenever you have a computer, because you can't store all that data in the computer or your MP3 player or whatever. So if you look at a graph of an analog signal, it would be continuous. Every single thing would be, if you were going to draw it with your pencil, you'd never lift the pencil up. Okay? But an analog signal would take it and it would just take a snapshot, and a snapshot, and a snapshot. It would just be discrete points. This point, then this point, then this point. Okay? Any computer, any electronic device that has anything to do with digital signals has what's called a DPS or a DSP, a digital signal processor in it. Like your phones have these things because you're talking into the phone. That's a physical process, an analog signal, and it has to convert that into a digital signal that it then processes it and maybe chops some stuff out, some stuff that it doesn't need, and then it sends it someplace, and then another phone picks it up, and then it converts it back to an analog signal that you can understand and you can hear. So I always want to put this up front when I talk about this, so it gives you something that you experience every single day of your life that has to do with continuous versus discrete functions. So let's look at this in terms of the actual functions. A continuous function then is one whose graph is unbroken. If you were going to draw it with your pencil, you would never lift up your pencil. You would just draw it with a continuous line. Continuous. I would never lift up my pencil. It's unbroken. And in discrete is just a set of points, discontinuous points. And you would lift up your pencil in order to draw the graph. Dot, 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 dot. And maybe your experience is something like that in an experiment in science, that you collected data and it's a data point, a scatter plot, right? It's a data point. It's a data point. And you don't necessarily connect all of those dots. So let's look at some real scenarios and determine if it's a continuous versus a discrete function. And then we also want to say what a realistic domain. Realistic or reasonable. What that means is, if it's a linear function, I might think it's supposed to be all real numbers, but for the real life situation, maybe negative numbers do not make sense for it. Maybe 0 doesn't make sense for it. Things like that. So number one, the cheerleaders are selling candy bars for $1 each to pay for new pom-poms. The function f of x gives the amount of money collected after selling x bars. So the function, writing it down, is pretty easy, right? It is $1 per candy bar, so it's 1x. You don't even have to put the 1 there, but that's what it is. There's the function. And if I were just to look at that function, I wouldn't know if it was continuous or discrete unless I connected it with this situation. So if it was continuous, I can sell any number of candy bars that I want. I can sell 1, I can sell 2, I can sell 1.5, I could sell pi of them, 3.14159. How many candy bars can I sell? And I can only sell them in whole numbers, right? So that makes this one a discrete function. Discrete. And its domain, it's a reasonable domain, even though that this, if I just had that as an equation, I'd go, hey, that's all real numbers. For this situation, I could sell no candy bars, 1 candy bar, 2 candy bars. I'm just basically saying the whole numbers, right? And I might go dot, 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 and I could leave it like that, but then I'm saying, hey, I could sell like infinite number of candy bars. So you might cap it off here. So some let's say fundraising programs might say that you're supposed to sell 50 of these things. So maybe this just goes up to 50. And so that could be the domain, the reasonable domain. Wherever you cap it off, that would be up to you. But don't leave it so that it's indicating that it goes on forever, because that doesn't make sense with the situation. They're not going to sell infinity candy bars. Okay, here's the last scenario. Kenny determines that his shower head releases 1.9 gallons of water per minute. He timed it, I guess, I don't know. The function v of x gives the volume of water released after x minutes. So let's write the function first and then do all the stuff to it. And this function is as easy to write as the other one. It is 1.9 gallons of water per minute, where x is the number of minutes. It just times it. It's like a slope. 1.9x. There's the equation. That's it. Is this continuous or discrete? If it's continuous, then all the water is coming out and there's no spaces in between when the water comes out in second 1 and when the water comes out in second 2. If it's discrete, it goes like this. How does your shower work? I don't know about yours, but mine is continuous. The water is always pouring out until I turn it off. So this is a continuous function. And now whenever I say a realistic domain for this, I'm going to go, let's see, how am I going to write this? Let's write this in set builder notation. And I would say a lower number on that would definitely be 0. Like I don't have to take a shower. Is less than or equal to x is less than or equal to. And then let's just figure out that maybe you take a 10-minute shower. I don't know. It depends on you and your shower. That'd be 19 gallons. Maybe we round it up to 20 gallons. Up to 20. And I cap it off someplace because realistically I'm not going to leave that water on forever, because who wants that, Bill? All right, so that's it on continuous and discrete. Continuous, it is unbroken. There's an infinite amount of information there. Whenever you draw the graph, you do not leave spaces or gaps. Discrete is just a set of points. There are spaces. It is broken up. Okay. So here, summarizing all this, we talked about the domain and range of both relations and functions. What it takes, number 2, to be a function is every input has just one output. Number 3, classify, is it linear versus a nonlinear function. Evaluating, plugging something into the function and getting an answer, an output. And then number 4, finally, what we just did, is this a discrete or is it a continuous function? There's one last cartoon for you, also involving a vending machine. It's kind of funny. And there you go. There's your assignment. Worksheet, definitely not optional. If you're in the complete flip class, please have that thing either printed out or you have your phone or something like that that you can work from. Okay? All right, see you in class.